Okay, so let's start. Okay, so see here, a popular drink is produced two similar bottle size. So when you see this similar, okay, the height, you're going to know that you're going to use all the height ratio, area ratio, and volume ratio. So they say that a popular drink is produced that the height of the larger one is 18, the smaller height is 12. Okay, so from here I will know that my H1 over H2. I always assign the H1 to the smaller one and then H2 to the larger one, although they put 18 and 12 here, because I want to get the fraction. Thanks, Rabbit Frog. Okay, so it will be equals to 12 over 18, and let's reduce it to the lowest term. Just press a calculator. 12 over 18, it give me 2/3. So for height ratio, take note, for height ratio is cm, correct? So the ratio is 2:3. So take note, every time is height ratio means that even today, if I'm going to talk about the diameter, it is also using 2/3. If I'm going to talk about radius, it's also using 2:3. Okay, so as long as it's cm, anything to do with length, dimension, as in cm, then you're going to use height ratio. Okay, so now they tell us that now the selling price of the bottle A and bottle B is these two amount. So they ask you which bottle provide a better value for money. So first thing is you have to ask yourself, okay, if we talk about money, it depends on the question. Not necessary that it must be related to volume ratio. Okay, sometimes it's area ratio. So it depends. So now you look at these two bottles. When you pay the amount of money, do you base on the amount of drink inside the bottle, or are you going to talk about, let's say, the area of the bottle, the surface area of the bottle? We don't really care about the surface area, right? Whether how your surface area looks like. I mean, what we want is the content inside our drink, correct? So the content inside our drink is volume related. So in this case, you will know that, oh, okay, the money ratio will be related to the, let me shift. I don't quite like that my face always get blocked. Okay, so in this case, I'm going to find my volume ratio first. So based on the height ratio, we can find our volume ratio. Just take the height ratio, 2, 3, and cube it. Okay, volume ratio is you cube it. So it will get 8 out of 27. So now let's find out which one is a better value. So for bottle A, okay, for bottle A is big one, so 27 units. So 27 units actually cost us $24.90. So let's find the 1 unit. So we take 24.90 divide by 27. So we have 0.9222. So it's like saying, okay, for 1 unit cube, we are paying 0.92. So we're going to do the same for the bottle B. Bottle B is 8 unit and paying for 6.90. So 1 unit will be 6.90 divided by 8, and that will give us 0.8625. So now look at these two comparison. For the same 1 unit or the cm cube of drink, one you pay 0.92 cents. The other one you pay 86 cents. So which one is a better value? Do you think it's the bottle A or do you think it's the bottle B? Which one is a better value? Boom, 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 boom. Bottle B, right? Because you are using lesser money to pay for the same amount of Yes, well done. Same amount of volume. So you will say now, therefore, bottle B is more value for money. But of course, in actual real fact, in reality, when you have two quantity, a small bottle and a big bottle, usually the big bottle price is better value, definitely one. If the supplier or the person who sell the bottle actually price the larger bottle less value than the smaller one, this kind of silly lah. That's not the correct way lah. But of course, we as a consumer, okay, we need to do our own calculation. Okay, not saying that big bottle means is better value. No, sometimes you'll be surprised that small bottle got discount, big bottle don't have discount. Then maybe the small bottle after discount is actually more value than the big bottle. Can I divide price by height? Cannot, because the price is not relevant to your height. Agree or not? Do you pay based on how tall or how short the bottle is? No. We are paying it, we want to be defined by the amount, the content inside the bottle. So we will have to use the volume. Understand? Yes, but that's a good question. That's a good question. Okay, so now let's move on to question number 2. This is a super tricky question. Question number 2. Actually, this question I see quite a few times. It's actually quite a pretty important question. Woohoo! Thank you for spamming like. Remember to like and share, like and share, like and share. Okay. Okay, so now let's take a look at this question. So a right solid cone is made up of frustum A, B, and C. Sorry, A, B. What is frustum? Frustum it's just a portion. So you need to know the A is actually just this part. The frustum B is the middle part. Cone C, this part here is a cone. That's why they call it a cone. Okay, next, the ratio of the slant height, see here, A is to B is to C. They tell us is 2 is to 3 is to 5. So they give me the height. So actually these are the height ratio. But you got to be very careful. Okay, so I'm going to write the small one. This is, okay, if you're going to look at, this is the smaller cone. The C plus B is a medium cone. Agree or not? The C plus B is a medium cone. A plus B plus B, A plus B plus C is the even bigger cone. So in order to find out the volume ratio, okay, see here, I need to find the correct length ratio first. So I'm going to write smaller one is LC, smaller cone. The medium cone is supposed to be LB plus C. The bigger one, the slant height is LA plus B plus C. So of course, common mistake is student go and take 5 is to 3 is to 2, which is not correct. So you need to add them. So LC alone is just 5. B plus C means you got to take 3 plus 5, so it's 8. The A plus B plus C means the all of them add together, so it's 10. So you see, the slant height of the smaller cone is 5 unit. The slant height of the medium cone is 8 unit. The slant height of the biggest cone is 10 unit. They ask for the ratio of volume A. Take note, volume A means they are asking for the volume of the frustum only. And then after that, the volume of the whole cone. So now with this, let's find out what is our VC, VB plus C, VA plus B plus C. So remember I said volume ratio, we're going to use the length ratio and cube it. So all of these three number, cube it. So 5 cube will give us 125. 8 cube will give us 512. 10 cube will give us 1000. So again, 125 is the volume of the smaller one. 512 is the medium one, which is the frustrum B plus the cone C. A plus B plus C is the frustrum A plus the frustrum B plus the C. Okay, so now see here, so therefore ratio of the A is to the whole cone. A is only the frustrum A. So how am I going to find the frustrum A? We're going to take the big one, big cone, which is about 1000 minus the B plus C. Understand? 1000 minus the 512 will give us the frustrum A. So this part is 1000 minus the B plus C, and that will give us the A. And the whole cone, we know that is 1000. So 1000 minus 512 will give us 488 is to 1000. So reduce it to the lowest term, so we get 61 is to 125. Done. Okay, so this one is a little bit tricky. You need to go and B plus C and A plus B plus C. You cannot work with 2, 3, 5. Okay? So then maybe some student may ask, can I just take, let's say 10 minus 5 first, then after that I cube it? No, you have to change it to volume first. Why not 2 cube is to 10 cube? No, you know why? Because you are using the length. You are using the length cupid, and then after that the length. You have to combine them together, because you see this one is a frustrum. So you got to change them to volume first, then you can minus them to find the actual volume A. So you cannot take just the slant height A, the slant height 2 and then cube it. Cannot. Because you must understand the length ratio, when we square it to find area ratio and cube it to find volume ratio, the underlying requirement is they must be similar solid. Correct? But when you take the slant height A is to this whole thing, but my A is to this whole thing, it's not similar. Agree or not? So I will have to use a similar shape in order to do the length ratio cubit. And that's why we need to change it to 5 is to 8 is to 10. Then that's called similar with the length ratio. Got it? So this is the tricky part. This is the tricky part. Okay, so now part B. Part B said, given that the volume of A is 122, they ask you to calculate the volume of B. Okay, so first of all, we already know that actually volume of A is 488 units, correct? So see here, so volume of A, we already know that it's 1000 minus 512, which is 488 units. 488 units. Okay, then before I know that I have to do 488 unit is 122 cm cube, but now is what is my volume of B? Okay, so now to find volume of B, can you tell me with these three numbers here, tell me which two numbers should I minus in order to get the frustrum B? Should I take 512 minus 125? 1000 minus 125, 1000 minus 512, which one? I want to get P. Hiya, so clever. Yes, okay, look at the alphabet. C and B plus C. So I'm going to take 512 minus the 125, then I will left with the frustum B. Good. Okay. So my volume of B, we know that we have to take 512 minus 125, that gives us 387. So now we can work out already. So we will say, okay, 488 unit is 122. My 1 unit will be 122 over 488. No need to go and find out the actual decimal, just leave it in the fraction form. I want to find 387. So 122 over 488, go and multiply by 387. And that will give you 96.75 cm cube. Done. No lah, I already did it. I already did my homework before I come live one. That's why I press very fast. Such a big number, how to calculate mentally. Okay, do you all get this question? Do you need me to explain any part? Don't have, so let's move on to question number 3. Pyramid. Okay, question 3. The base of the pyramid is a rectangle of side 36 by 48. V is vertically up, so what I'm going to do is dot dot dot, like that. Above the center of the rectangular base, the slant height is 30. Find the vertical height of the pyramid. Okay, so actually this one I just need to draw this. I will draw it out here so that you see what I mean. So we actually have already 30. This side will be 36 divided by 2. 36 divided by 2. So this one will be 18. So we are trying to find this. So this one simply just use Pythagoras theorem. Okay, so it will be H will be equals to the hypotenuse square minus the 18 square root, and we get 24 cm. This one is already another topic, which is the volume total surface area of pyramid. I hope this one you all know. Okay, then now the part B. Part B say, okay, now a smaller similar pyramid 64 cm cube is being cut out from the top. This is your pyramid. So it's like saying that my drawing a bit sucks. They're trying to say they remove a top. Then the top is a mini pyramid which is 64 cm cube. So they ask you to find the height of the smaller pyramid. So see, the keyword again, similar pyramid. So in order to find the height of the smaller pyramid, I need to find my volume ratio first. So now the question is, how am I going to find my volume ratio? I have the smaller V1, but I don't have my bigger V2. But am I able to find my bigger V2? How am I going to find my bigger V2, which is this big volume ratio, this big volume? It's testing your previous, you're testing your other topic, the volume of pyramid. What's the formula to find volume of pyramid? 1/3 multiplied by what? This one is a pyramid. The base area is a rectangle. So volume of a pyramid formula is 1/3 times base area times height. Okay, so I'm going to just put base area times the height. And in this case, because the base area is a rectangle, so therefore it is 36 multiplied by 48. And the height, we have found it over here, which is 24. So A, B, C, D, you are correct. So 1/3 times base area times height, and then check your base area. Oh, my base area is a rectangle. That's why I just use length times breadth. And then the height of the pyramid. Height of the pyramid, which we found part A. So now we have 13824. So this is the bigger ratio. So now actually I have my V1 over V2 already. My V1 was the one that was removed, 64. then the big one is 13824. If you reduce this to the lowest term, you get 1 out of 216. So remember just now our question is to find volume ratio, we cube our height ratio or length ratio. Now is I have my volume ratio. In order to find my height ratio, I cube root it. Okay, so to find my H1 over H2, you cube root your 1 out of 216. And therefore you get 1 out of 6. So therefore you know that, oh, my height ratio is 1 over 6. Now, let's continue here. We actually have our height 2, correct? Just now, the height 2 is our 24. So, it's only the height 1 you are supposed to find. You will leave it as unknown. So, it's H1 over 24 is equals to 1 out of 6. And then, cross multiply. 6H1 equals to 24. So, H1 equals to 4. And that will be the height of the smaller pyramid. Done. Ta-da! Okay, now let's go to question 4. 2 more questions to go. This one. This is the graph of other rates of change. Come. Anyone know how to do this kind of question or not? It's surprising. See, this is 1 mark, you know. But this 1 mark is also not easy to get. Okay. We left with 2 questions, question 4 and question 5. And today I think maybe, you know, we might end early. So how? Anyone know the answer for question number 4A? It's just a 1 mark question. Are you able to get the 1 mark? How? Anybody are able to get this 1 mark? Find the time taken for the water level to reach 10 cm. Okay, think along the line. My hint to you is the time. Ask yourself the time ratio, because there's two different shapes here, right? So the time ratio will be relevant or related to what ratio? Okay, that's my hint to you. And then see whether you can get this 1 mark. It is the height will be related to the water. The container was initially empty, correct? And then it takes 35 seconds to fill up the container at a constant rate. The water is being added in, right? Filled up. So the time ratio is related to the volume of the water. Therefore, it is related to the volume ratio. Okay? So, we will have to say T1 is to T2. T1 it will be the smaller part. And then T2 is equals to the volume 1 is to volume 2. So now then my next question is, do I have my volume ratio? So we have to find the volume ratio. So this part is my V2. The V2 is easy. Yes, ABCD is not using the height. It's using the volume ratio. So got to be careful. The time related is related to the volume ratio. So V2 is easy because it's a cuboid. So it is 15 times 15 multiplied by 30, and that will give us 6750 cm cube. Okay, now this one, V1. Let's see how many people can get it right for getting the volume of the smaller one. You all sure will say 15 times 15 times 10. But no, take note, the bottom one is not a cuboid. How do you find the volume 1? Say, you look at you cover the cuboid, and then just look at the bottom solid stand alone. Ask yourself, what solid is that? What solid is that? What solid is the bottom one? It has a uniform cross-sectional area. So what shape, what solid is the bottom one? It has a uniform cross-sectional area. Okay, so the trick is This one, the bottom, this is a cube, so this is not. This shape here is a prism. A prism has a uniform cross-sectional area. So in this question, the uniform cross-sectional area is the triangle. You can see the so-called top and bottom, I mean the front and the back is the same shape, right? So this is a solid with uniform cross-sectional area. Therefore, it is a prism. Okay, volume of a prism is base area multiplied by the height of the prism. Because this, you see, this triangle that you see, the triangle in front is the same as the behind one, correct? So that's called a uniform cross-sectional area. That's why it's a prism. So for volume of a prism, the formula is base area times height. And our base area in this case is a triangle. So equals to half times the triangle. This is 15. The height is 10. Now, take note, height of the prism is here. In this case, it is 15. So therefore, it is 1125. 所以这个 1 mark 不容易拿. This 1 mark not easy to take. Because you need to know that the bottom is actually a prism. So now, my T1 is to T2 is volume 1 is to volume 2. Okay, so you will take 1125 is to 6750. Reduce it, you get 1 is to 6. So the time for the bottom one is 1 unit. The time for the bigger one is 6 unit. And we know that to fill up the whole tank, it is 35 seconds. So therefore, 1 plus 6, you know that 7 unit will be 35 seconds. They want to know the time taken to reach the 10 cm. That means it's only just 1 unit. So therefore, 35 divided by 7 is equals to 5 seconds. Answer. I spell out, okay? 5 seconds. Okay, so now we know that it will take 5 seconds to fill up to here, and then you will take another 30 seconds to fill up to the brim. Okay, so now this part B here, they say on the grid below, you are supposed to sketch the graph of the height of the water against the time. Okay, so there's 2 critical points that you need to mark out. First is up to the 10 cm. Okay, up to the 10 cm, right? And we know that it takes 5 seconds. So that means this is the first point. Take 5 seconds to fill up 10. Then after that, the remaining up to 35, it will reach up to the 10 plus 30, so it's 40. So the final point here is here. Total 35 seconds, 5 plus 30, and then it reached up to 40 cm height. So that's the 2 main points that you need to plot first. Then next is you need to draw the shape. Okay, you only have 3 types of shape that you need to draw. I'm going to put here. Okay, you only have this, and this. These 3 types. Of course, this is increasing. This is for increasing. If it's decreasing, then it's the other direction. If it's decreasing, then it's the other direction. This is talking about increasing. Okay, so now let's analyze this part. The bottom, because it's from empty to fill up. So you imagine from bottom to up. Do you think the time taken is getting faster or getting slower? From bottom to up for the 10 cm, do you think it's going faster when you fill up or going slower? Slower? Yes, we will go slower. Why? Because you can see that the bottom is smaller, right? Then it's getting more volume already. So that means it will slow down. So it will slow down. No, it's not the same. The same is at the top part. this bottom is not the same, because it's not, imagine the water you fill up here, so small, then after it very fast fill up the bottom part, then after it become bigger and bigger, so it becomes slower and slower. Okay, so it become slower. So in this case, slower is this one. This one is slower, this one is constant, and then this one is faster. So it will be this shape. So from here to here, you need to draw the shape. Make sure you show the curve, the curve part. So I will do like that. Hoi. Then from here to here, because this is a cuboid, and you can see that from here filled up to here is constant already, because the shape is the same, right? So in this case, it will be the constant, which is a straight line, and therefore you will draw from here to here, just draw a straight line. Yes, constant, correct. That's all. So that's how you draw. Okay. Yay, we shall proceed to our last question. Okay, so now an open container in the shape of an inverted cone. So inverted cone looks like that. Okay, I don't draw very well, as long as you know that it looks like a cone can already. They tell us it has a radius of 10 and a height of 30. Water is poured into the container at a constant rate of 5 pi cm cube per second until it is completely filled to the brim. Find the time taken for the container to be completely filled. So this is my so-called the rate. So the rate given to us is 5 pi cm cube per second. So now, in order to find out the time to fill up, I need to find the volume of the cone. So volume of the cone, come, what's the formula to find volume of the cone? What is the volume of the cone? What's the formula? Area, are you my area? One important fraction. So it should be 1/3 times base area times height. Okay, remember there's a vertex. Remember just now the pyramid, we also have vertex. The base area is a rectangle, we use the length times breadth, correct? This one, the base area is a circle, so it is 1/3 multiplied by pi r square because it's a circle, and then multiplied by the height. So always check whether they got ask us to use any pi or not. Okay, I'm not going to use any value pi. Why? Because over here my rate got pi. So I'm going to just keep it in terms of pi. Radius square, so 10 square, and then the height is 30. So in terms of pi, we get 1000 pi. So to find the time, I take the 1000 pi divided by 5 pi, it is 200 seconds. Done. Last part. Sketch the graph of the water level against the time below. Yeah, this one definitely also more than 1. I think they are like assuming that you all know the formula 1/3 times pi r square h very fast. That's why they only give you like 1 mark. Okay, see here, sketch the graph of the water level. So we will draw this side will be the time in seconds. This one will be the height, cm. From, imagine the water is being filled up. Why the screen disappear? From here, you move up, You sure it is a straight line? Fast to slow. Unless it's a cuboid, then it's constant. A, B, C, D. unless it's a cuboid, then it's constant, then it's a straight line. But this one is, you see, is from small to big, so you are going slower. So if you are going slower, it will also be this shape, right? So if it's this shape, this one very straightforward. It is only 200, then here 0, and then the height, it is just 30. So this one only have one point that you need to plot. Dot. Okay. Yeah, so it will just be the shape that is just like that. Hoi. Yes. Okay lah, can see the curve lah, Okay, it must be this shape. Okay. Okay, if today they tell you that it is not an inverted cone, it's like the other way around. If let's say they I draw it here. If let's say it is this one, but of course if it's this one, then it will not be an open container. Okay, this side is open, that's why I can pour water inside Of course, if it's this direction, then of course we expect to have a little hole here lah. If not, cannot put inside. Okay, so if it's like not inverted, then if the water is from bottom filled up, so you can see that it's become big to small, right? And then you will have to choose the one that is going faster, which is this one. Understand? So you got to be very careful and see whether is it if it's for increasing. Okay, if it's increasing, then you got to analyze. Oh, okay, this one, if I pour in, is from big to small, so it's getting faster. This one is filled up water, so it's from small to big, so it's getting slower. So if it's this kind of shape, it will be, I just draw a mini one here, it will be like this direction. Okay, I hope you all learned something today. The concept is not tough, right? So yeah, so we are done for the day. Not too bad.